Hello and welcome to 5.5 Notes. So already to start off at the beginning here, it says draw an obtuse scalene triangle. And I realize that we've just started the lecture or the presentation, but at this point already you can pause the video if you'd like and draw yourself an obtuse scalene triangle. But for the sake of this presentation, I'm going to continue. So after you've drawn the obtuse scalene triangle, you need to find the largest angle and the longest side. And then, step 2 would be to find the smallest angle and the shortest side. And then, what do you notice? What relationship between the largest angle and the longest side, and similarly, the smallest angle and the shortest side? What do you notice? What relationship do you notice? So this is the obtuse scalene triangle that I'm going to draw, that I've drawn, and I'm going to look for the longest side. I can just do that visually. No need to bring out a ruler or anything like that. You can just visually see that that is obviously the longest side. And similarly, you can see that this is the largest angle. After all, it's the only obtuse angle in the triangle, and clearly the other two are acute, so it must be the largest angle. And now I've copied and pasted the exact same triangle right here. I just thought it would be easier for me to show you, easier to get the concept across to you if I copied and pasted. It's the exact same triangle, but I am now going to try to find the smallest angle and the shortest side. So here is the shortest side. Again, you can just see that visually. And here is the teeny tiny little angle, the smallest angle. So what do you notice? You can pause this video if you'd like, but again, for the sake of this presentation, I'm going to continue. And hopefully you've discovered on your own that if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So we have, for example, in triangle ABC, we have the measure of side AB is greater than the measure of side BC. So then it follows that the angle opposite AB, which in this case is C, is going to be greater than the angle opposite BC, which in this case is angle A. So we have this. That if the measure of side AB is greater than the measure of side BC, then it follows that the measure of angle C must be greater than the measure of angle A. And the converse of that statement is also true, that if one triangle, if one angle of a triangle is larger than another, then the side opposite the larger angle is longer than the side opposite the smaller angle. So if you have this triangle, then triangle ABC, obviously 50 degrees is greater than 30 degrees, so the measure of angle A is greater than the measure of angle C, and the side opposite angle A, which is side BC, is going to be greater than the measure opposite the 30 degrees, opposite angle C, which is side AB. And, give me a moment here, that's what it says here, that the measure of angle A is greater than the measure of angle C, so the length of BC must be greater than the length of AB, because the corresponding opposite. So it's large angle, large side, small angle, small side, and vice versa. So that's the concept there. That's the first concept you'll be responsible for. Okay, and here's a typical problem you'll get regarding this concept. List the sides of triangle RST in order from shortest to longest. So if you'd like right now, you can pause the video and work this problem out on your own. But again, for the sake of this presentation, I'm going to continue. So we want to list the sides from shortest to longest, and we're talking about the sides, right? So the clues that we have are that starting with the smallest angle, and clearly 29 is smaller than 121 or 30, so 29 is the smallest angle, then the shortest side must be opposite that, which would be line segment ST. So I would start off with that. That would be my beginning. The measure of ST is going to be less than the other two, so there's my beginning. And then the next angle up is 30 degrees. And if you notice, 30 is just 1 degree above 29. So this length and this length, in reality, I don't know if I've really drawn it to scale, but in reality, they would be really, really close, and you'd be hard-pressed to find a difference even if you measured with a ruler. So that's why this concept is important, or it's useful. If this is just 1 degree larger, then you know that this has to be longer than that RS has to be longer than ST. Okay, so let me get rid of that. So again, if this is the one that's in the middle, then the next side or line segment is going to be RS. So here's my next one, RS, which will be less than, and then the longest side is opposite this large angle, which is 121 degrees, and that would be side RT. So RT is the largest. So that's the answer right there. It says list the sides of triangle RST in order from shortest to longest, and that's it right there. ST is less than RS, which is less than RT. Okay? Makes sense? Okay, moving right along. I would like you now to sketch and label a right triangle with sides that are 6, 8, and 10 feet long and angles of 90 degrees, 37 degrees, and 53 degrees. Put the shortest side on the bottom and the right angle at the left. Okay? You can pause this presentation now and give it a shot yourself, but for the sake of this presentation, I'm going to continue. And I just want to point out, it says sketch and label a right triangle and with sides that are 6, 8, and 10, and then angles of 90 degrees, 37, and 53. Well, of course, if it's a right triangle, then one of those angles has to be 90 degrees. That is a little bit redundant, but just to clarify. Okay, so I'm going to skip frames here, but it says the exact same thing, so no need to recopy that down. I did that mainly for the class, so I can just move on and people can still continue to take notes. Okay, so let's continue. So let's see, put the shortest side on the bottom and the right angle at the left. So I would start off like that. There's my right angle, and it's towards the left, and I'm going to make this side the shortest side. Okay, so far I'm setting that up like that. Then I might as well just connect, sorry, what's happening? Oh, didn't mean to do that. What is happening? That is weird. Hold on for a second. Get rid of that. Aha, that's what I want to do. So I might as well connect, so we have our triangle. Okay, and then this is the shortest side right here. That's the shortest side, right? Shortest side. Boom. That's the shortest side. So then it follows that opposite that short side must be the smallest angle. So I can just start off right there and put that's 37 degrees because I know it's opposite the shortest side. And then that's the remaining angle, right? The 53 degrees. If I have, I only have 3, that's 90 degrees, which is right there. And then this is my 37 degrees, which is right there. So by process of elimination, then 53 degrees must go right there. Okay? So we have all the angles in the right places. Now we just need to put the 6, 8, and the 10 in all the correct places. Well, clearly, this being the shortest side, we know that that's going to be the 6. And now we have to decide where to put the 8 and the 10. Well, the 10 has to be the hypotenuse because the hypotenuse, or the side opposite the right angle, is always the longest side. So the longest side is 10, and then that leaves 8 for the other leg. So that is what that would look like. Okay, so if it says sketch and label a right triangle with sides that are 6, 8, and 10 feet long, and angles of 90 degrees, 37 degrees, and 53 degrees, and we need to put the shortest side on the bottom and the right angle at the left, this would be the picture you have right here.